Apologies for getting in here a little bit slow. It's been a minute since I've done one of these live streams. Who's in here? Jump in and say what's up. Okay, so I'm going to be doing a gradient Wariha Tetsu today. So that means I'm taking some gradient material that I've actually already forged out. I got this bar here. This needs to be cut up and restacked, welded back together. But first, there's forge scale on it. So I gotta grind that forge scale off. Then I'm gonna get it cut up. Then I'm gonna get it stacked up, welded. And then we're gonna get it into the forge. That forge right there, it's getting up to temp. It's actually pretty close to temp, I think, already, actually. So, I guess that's it. Here we go. I need a pair of gloves, because this grinding gets pretty hot. If anybody's got any questions, feel free to jump in and say so. I can't remember if I might have screwed things up. I don't know if it's allowing a chat or not. Let's see. Doesn't say. Anyways, yeah. So if anybody's got questions about what's going on, feel free to jump in and ask away. Otherwise, you're kind of just going to be hanging out with me and following along. I will warn you, there are parts of this process that are going to be really loud and noisy. That's just the nature of this work, as some of you may know. So you might want to turn the volume down. This next part is probably going to be a bit loud. So I need my, let's set you down here for a second. I need my respirator. Gloves. I owe a big shout out to my buddy Evan Davis who set me up with this thing. This thing is rad. This is a JSP power cap. It's forced air, so it pulls air from through the filters, through the top of the bill of the cap and into the mask, which allows me to safely have a beard while working in an environment full of dust. Let's get this going already. All right, I won't be able to really talk while I'm wearing this. Trust me, I know that sound is pretty terrible in there. Apologies again. Alright, so I got the billet all cleaned up. Now I gotta mark out lengths and I gotta cut the bar down. So what I did is I cleaned the faces of the bar, both faces as well as the edges. So now I'm gonna measure the length, split it up. We're gonna stack it back up, or cut it up, then stack it up, and then get it into the get it welded and into the forge. So I need to find a measuring tape. I think I know where one's at. I will be right back. Alright, back. Handy dandy. Let's see what we got to work with. So, bar's still not too hot actually. So, when I'm looking at trimming down my billet, I look to see what kind of funk is happening down at the end. And you can see where it starts kind of deep and then works its way out to the edge. So I'll basically, where it goes to the edge, I'm gonna call that basically the functional end of the billet, the end of the billet that has material that's actually worth using. Doesn't have to be perfect, but you don't want to put too much schmutz at the end of your billet. You want to keep it out of your billet. So now I'll measure the length of the billet, and looks like I got 32.5 inches. Now, I already got, let's see. Ooh, might be hard to see. I don't know if the camera's gonna focus on this very well. Let's see. Or if the light's even gonna catch it very well. Anyways, I look like an idiot. There are layers at the, oh, almost had it. The end of the billet. Let's see if I can try to get the focus on that spot. No. Anyways, there are, I think, let's see, how many layers am I seeing? 2, 4, 6, 2, 4, 2, 4, 6. So there's about 14, 15 gradient layers in this billet already. So what I'm going to do is I'm making a Wariha Tetsu construction. So basically I'm going to make, let's see, for the final weld, I'm going to do 4 quadrants. 3 of them are going to be the gradient material, and 1 of them is going to be solid black material. That solid black will then become the edge of my knife as I forge out a chef's knife that essentially has like a sanmai aesthetic, or it's a sanmai construction, but in traditional Japanese sword smithing, this would essentially be a bit weld or an edge, or edge weld, kind of a taco weld. But basically, they would cut the soft material open, insert hard material, and then weld it back together. I'm roughly doing the same thing, except for using a mosaic Damascus approach. I'll do a little drawing to help clarify that concept. But really, the biggest thing right now is getting everything chopped up and put into the forge. Then we'll have some time to talk. So, 32.5 inches. Let me grab my calculator. And my calipers. Let's see. Holy smokes, they got a lot of stuff with it. All right. So, the question is, how many pieces do I want that cut into? Probably 10. I feel like 10 would be a lot though. Because I got to think about the idea that there's going to be, essentially, if I do 10, it's already at 15. Then that's 150 layers on one side, 150 layers on the other side, and that potentially could present very coarse, which is not exactly what I want. I need to measure the width of this thing. Width is 1.5. Thickness is it's about 1/4. Let's see, how many pieces to get 1 1/4? I guess 5 pieces would give you 6 pieces. So I want to go as few as possible. 5. So I did 1.5 divided by 2 is 0.75 or 3/4. Added that back to 1.5 because I want to at least go through 30% reduction in my stack, but to figure out that height to get down to that 1.5, I had to do that math. So that means a 2 1/4 inch tall stack will give me a 30% reduction to get down to 1.5 by 1.5 inch square. And then, yeah, so then I need to just figure out how many pieces. 9 pieces to make that tall of a stack. Then what I'm going to do is I'm going to divide 32.5 divided by 9, 3.61. What does that even mean? That's how many pieces, or that's how long the piece is going to be. So, what I like to use are my handy dandy calipers, and I will open them up. These beautiful calipers. Love these things. It's Mitu Toyo is the brand. So I'll open my calipers up to 3.61. I'm going to check the consistency of the thickness on this thing real quick. There, a little bit there, right on. Okay, that's not too bad. Alright, that's pretty good. It's pretty consistently 1/4 inch. So my guess is that I forged this bar to 5/16. And through contraction or shrinkage, actually when it cools down, as well as cleaning the forge scale bark off, that got me down to 1/4 inch. So again, I'm going to open this up to 3.6. What was that math again? 3.61. 3.61 forever. All right, so we're going to lock that in. 3.61. Now, I need to go find where handy dandy square, and I am now going to show you the embarrassing mess in my shop. All right, so I got my square, I got my calipers. So what I'm going to do, I'll flip this around here maybe, that makes more sense. I'm going to use my calipers. These are carbide tip calipers. So I can use this caliper to mark the end of my bar. Or mark out my spot on the bar of steel. Let's see. Yeah, right there. That is my, oh gosh, hard to see a little bit. All right. I'm not catching the right light. There you go. This is my spot. Now I'm going to use my square. And I mark the next spot. And I'm going to keep working down the length of the bar. marked out all my pieces. Okay, so I made all my marks. You can see all these lines going across all the way to the end. And look how our math ended up working out. The last one is right there. Now, I got my start making stuff doing woodworking. And in woodworking, you always have to take the saw curve into consideration. And that is something I used to always do. But I realized, one, it was taking extra time to do that math. But two, if I cut them all on the same side of that line, so from the end here, let's turn this. From the end here, if I cut on this side of this line, and I do that consistently all the way down the length of the bar, all the pieces are going to be the same length without having to think too hard about the saw curve. So now I'm just going to take a pen. One thing I do like to do is I'll run a line down the full length of my billet. So I'll just go like this. Right? Now I got a line. By the way, this is an industrial Sharpie. Love these things. And then I'm just gonna number each one of these. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, because I already have these all marked out, I don't have to cut them in sequential order. I can cut them wherever I want. Right now, I'll probably start actually by cutting it at between 5 and 6, so that I don't have such a long bar that I'm trying to navigate on my bandsaw. One of the benefits of doing this, you might ask why you put the line at the bottom. It helps to keep track of what way the billet was oriented when you originally put the numbers on there. Because some of the numbers can be misconstrued, especially if it's just a slash for one. Which side's right side up, and which side's right side down. So, and number 9, number 6, sometimes number 8, depending on how you draw your 8s. Anyways, we got some people in the house, by the way. Rick Elm. We got Anchorage Forge. What's up, everybody? We got our friend Michael Forge. We got 73 Forge. What's up? What's up, what's up, what's up? Okay. If anybody's watching this over on the Patreon, by the way, if you want to figure out how to get over to the YouTube so you can add comments and ask questions along the way, go tap your screen, go to the bottom right corner, I believe, hit the YouTube logo. It'll help take you there. Evan Davis, I was just shouting you out earlier, buddy. Love this thing. I threw on some lights. I love it. It gets the job done. All right, I'm gonna actually throw that mask back on. I'm gonna go cut these up. It's super noisy in the it doesn't matter. It's gotta get noisy. Turn the volume down, whatever. And yeah, that's it. Here we go. Love this thing. There isn't a ton of room in my grinding room, so we just work with what we got. Sometimes I get people poo-pooing me for using a little bandsaw like that, but it's pretty fucking quick compared to putting in a saw or a horizontal bandsaw, at least for that kind of thing. Setting it up, clamping it, marking it, or using a stop or whatever every single time. Just mark them and cut the fucking things. Alright, so now I got all my pieces. I actually left the handle in the other room, so I'm gonna go grab that real quick, and then I'm gonna weld these on. This handle, real quick, from that last billet, when I welded it up, the handle is actually an isolated part of the end of that billet. So like the end of it, isolated, and forged out into a little square stock that I could hold on to with my V-bit or V-jaw tong. So I'm gonna weld this back on. Actually, feels kind of long. Well, actually, trying to decide. Actually, you know what? I am gonna cut that off, and I'm gonna cut off this little extra bit. One, because I could forge some little fuckadoo, little play around, fuck it off knife out of this little Damascus chunk. But two, I feel like it's gonna be a lot more stable if I weld on this part. So I'm gonna go do that real quick. Let's take you guys over to the forge. You can enjoy some forge ASMR. Open this up a little bit. Be right back. Okay, I got my handle. I also knocked in a little chamfer around the edges. So this thing's ready to weld up. Like bore. I also meant to show you that process for cutting those down worked perfectly. If you had any doubts, I don't blame you. But I'm gonna show you. Flush across the bottom. There. On the anvil, flat across the bottom, flat enough across the top. And yeah, I didn't have to spend forever measuring and calculating for saw curve or any of that stuff. It's all stuff. I'm not poo-pooing anybody. That's all stuff I used to do, and I decided it was a huge waste of time. So the way, just because it takes 2 seconds to do this, maybe 20, whatever. I'm gonna kind of Jacob's ladder this thing. So these two pieces came off the bar like that, right? 8 and 9. I'm gonna fold those onto each other. And then I'm gonna put 7 and 8 back to back. That. So that does kind of a Jacob's ladder. And then 7 and 6, face to face, and so on. In the restack. Just so things kind of line up just a little better. So 6 and 5 back to back, 5 and 4 face to face, 4 and 3 back to back, 3 and 2 face to face, 2 and 1 back to back. That's it. Sometimes I call it mirroring across the weld face. Call it all kinds of stuff. All right, gonna get ready to weld these guys. Slap a little weld on here. Let's see, we gotta get this welder plugged in first. clogged up. Apparently I didn't close the gas last time. It's not great. Since last time I welded, you guys were watching. That was a while ago. Good idea to close the gas up. Alright, let's see. Gloves, mask, and a spark. Turn this up a bit. Alright, here we go. Again, massive love to my friend Evan Davis who set me up with this thing. Love it. that dang handle on there. If I can find it. Whatever. There we go. And what I like to do with these little nubs, well, that's not that small enough, but anyway, you end up with a bunch of little nubs when you're TIG welding. So what I like to do is keep them handy, and what I will do is I will lay them down right along where I'm getting ready to weld the handle on. That one fell off. Anyway. So I'll throw that in there. So I have some material laying there, ready to go. Welder. It's not really meant to help make the whole weld, just to help hold things together so I can tack it, and then I'll go back in there with the stick. That handle is hot. God damn. My glove's hot. My hand's hot. Alright. I'm gonna get this in the forge and then we can talk about what's happening here. How that handle fits perfectly. It needs to be a bit jaws. Love it. Love it. that was running only at about 30 psi, or sorry, 20 psi. It's now running at about 30. I'm good with words, I promise. Let's see. I'm trying to get this tripod figured out. It's a little wonky right now. Not sure if it's this. Excuse me. But anyways, okay. Oh yeah, I was gonna get a pen and pencil so that I can illustrate what's going on here. That's gonna soak probably for about whatever. I don't know. I'm gonna get it up to temperature. I'm gonna let it soak for maybe about 10 minutes or so. So when I say bring it up to temperature, I want it to match the temperature of the forge. And then I'm going to set the initial weld. Then I put it back in the forge, turn the temperature down just a little bit, and let it soak for a while. But while we're waiting for it to come up to temp, I'm gonna go grab a piece of paper. So please enjoy. Back. First off, can you guys hear me all right? I know there's a lot of noise going on right now, and I just want to make sure you guys can hear me. Okay, so I'm not going to write any words because they're going to end up being backwards on this. So unless there's a way to mirror, no, what is that? I don't want that. Cool, loud and clear, Evan says. All right, so what we're doing, we're making a Wariha Tetsu with gradient elements. So I already had a stack of gradient material. I think, actually, I got another chunk of gradient that I forged a while ago. Try to get that to focus on that. Oh, there we go. A little bit. See it just a little bit. Anyways, the silver is thicker on the bottom and then gets thinner at the top. And the black is thicker at the top and gets thinner at the bottom. Anyways, so I gotta build it like this, and I forged it out to a bar, and then I stacked it up 12 or 13 times, I don't know. But it creates, because it's half, essentially that bar becomes half black, half silver. Even though I cut it into 12 pieces or 13 pieces, it ends up with a couple extra half pieces essentially on the outside. So it's already at 15 layers. And I just cut it into 9 and stacked it up. And they're getting nice and warm. And let's see, turn this a little bit so you can see that as well while I talk. Okay, so the plan is I got my bar. Oops, this pen doesn't work. There we go. Got my bar. Got my 15 layers in there. I stacked it up. Just cut it times 9 pieces. Stacked it up. It's 1.5 inches by 2 1/4 inches because I want the stack to go through 30% reduction of the height before I start working on the edges at all. And so I'm going to work it down to 1.5 inches. It's 1.5 inches wide right now, but it's 2 1/4 inches tall. I'm going to work it down to 1.5 inches tall before I start turning it on the edge and start working on the edges. Let's see. Hey, that kind of works. that down to a square. And I want that square to be 1.5 by 1.5 because my Damascus making material is 1.5 inches wide. Now it's only 1/8 of an inch thick. Now, what I'm going to be doing is I'm going to be doing a Wariha Tetsu construction. So I'm going to draw really quick what that looks like. Oh, anyway, sorry. So I'm going to forge it down to 1.5 by 1.5. And, actually, I might have to go smaller because I need to get 3 pieces out of this. Because, actually, I know I'm going to have to forge it out smaller to probably 1 inch by 1 inch, which is great because I also have 1 inch square stock. Anyways, we're going to skip all that stuff I was talking about, the 1.5 inch. Wipe that from your minds. Pretend that never happened. So anyways, so we're going to forge it down to a square. Then I'm going to forge it on the bias. So that, and essentially re-square it. All of those pieces are then running diagonally. Let's see where we at, right there. So we're going to start square, turn down on the bias, and then re-square it to create a diagonal, or that diagonal activity. And the reason is because I'm going to put them in a 4-way construction. So I'm going to cut that bias material times 3 pieces. Only 3 pieces because the last piece I'm going to insert in the 4-way. I'm going to weld in solid black material. So 1084 I have. So I'm going to have 4 quadrants, but one of them is going to be solid black, which is why I'm only cutting it into 3 pieces here. For the Patreon, I'll take a picture of this and I'll post it up. The reason I wanted it forged on the bias like this is because ultimately I'm going to weld this up and that black piece, that black quadrant is going to become my edge material. And the gradient is going to act as cladding essentially. But for it to be flowing the right direction, I had to forge it on the bias. So that, it looks like that. And then this is the gradient, these 3 quadrants is the gradient material. And then once it's welded, I'm gonna flatten it out to a bar stock that I can then forge a sandbite out of. Now I can also tile this, and actually there's probably gonna be plenty of material left in this to tile it. Actually, I gotta flip this over real quick. Alright, it's flipped. So I'm just drawing this, what the bar is going to look like. black material, that doesn't look very solid black, sorry. Scribble that in just a little bit more. The black material will end up becoming the edge material, or the edge of the bar. The reason I came up with this construction is because when I'm forging an integral, I really struggled to keep that edge bar, especially, centered on the billet when I was forging it out. So, as well as, I guess, kind of, I don't know, I was struggling with forging integrals that had a sandmine kind of quality to it. And so this was kind of my way to cheat it. Oh yeah, I was like, what was I going to draw? I was going to draw something. All right, so a traditional construction, the Wariha Tetsu construction in a Japanese sword blade. This is a caricature. Look it up. You can find pictures of this online. Essentially, it's a bit weld. But when I saw a picture of this, I was like, holy crap. I know how to make that. I've seen that before. And it's with a four-way. And I was like, oh, I never thought about adding black into one of the quadrants while the rest of the pattern is in the other three quadrants. And so there are a couple ways, like I said, you can use this. You can tile it, you can just cut a chunk off and forge a knife out. You do have to keep track of which edge is the edge. But then the other process is to tile it out and then forge it out. And that way you still have that bold black along the edge. You have that that sandmine aesthetic, but you're kind of blending it with the mosaic Damascus pattern approach. So Evan's asking, does this also help not grind through the cladding when doing S-grind? And 100% it does. Because I'm going to draw another cross-section. This is not going to be perfect. Again, a caricature. But hopefully to help illustrate what's going on. Essentially, this is your core material, and then this is all of the rest of the cladding, the pattern material. When you once you get the blade forged out. So even if you do grind in like an S grind, you're still going to have pattern in that blade, and you're less likely to grind through the core or grind into the core of the sand mine by using this Wariha Tetsu construction. Yeah, so the steel is solidly come up to temperature with the forge. So I'm going to let it soak for a few minutes. And, no thank you. Nobody wants that. And answer any questions that you guys might have. Let me scroll back through here. Please give a shout out, say what's up. This is not a sword. But that is a good question. That is a fair question. This is a Damascus pattern inspired by Japanese sword construction. Wariha Tetsu, I'm probably butchering that, I apologize. Maybe it's Wariha, I think it's Wariha, I don't know, I've never heard it pronounced. But anyways, Wariha Tetsu blade construction to create a sandmine aesthetic, or a sandmine construction, or a presentation of construction, while mixing it with a Damascus pattern of some sort, whether it's mosaic or non-mosaic. This pattern is not going to be mosaic, this is just going to be kind of like a random pattern cladding. I will be interested to see how it looks And you know, it's interesting. I've never thought about the idea of like trying to ladder this, but this is also probably a really great way to create a laddered effect on a Sanmai style blade without getting the core off center. Because there's always gonna be a portion of the blade that is just core material. Yeah, that should be actually. I'm curious now. Part of me, I probably won't do it on this one, but like I said, there's gonna be tons of material. I think there's gonna be, let's see, let's do some math real quick. Figure out the volume of material that we have right now. Alright, so we're 1.5 wide by 2.25, 2.25 tall. What do? We cut these down to 3.61, we'll just call it 3.6. So that gives us 12.15. Now, if we assume that that's going to get forged down to a square bar that will only have 3 pieces taken out of it, I'm now going to be, in the next step, going to be adding black material into one of the quadrants. Yes, Rick, no flex. That means I can add another 4 cubic inches of material, 4.04. And then, so that'll give me 16.19 or almost 16.25 cubic inches of material. And I know that with just 2.5 cubic inches, I can forge a blade. That's going to give me 6.5 blades of material. It's not bad. So, and because I'm going to be forging it out like a traditional, just like a Sanmai, I'm not going to be kind of like, I don't have to forge it to profile. I can actually, the more forging I do, it will benefit the texture and activity of the blade. So I'm going to forge it pretty close. Yeah, I'm going to forge it pretty close to the heat treating dimension. Let's see. That's right. Am I in hell? Zero Fox, I'm close to it. This forge is running at about 2200 degrees. I'm going to rotate that steel real quick, actually. It's getting hot there. Not getting hot. It is hot in there. Well, let's turn this camera around. See if we can see. The steel is damn hot. I'm hot, and this is why you're not. Yeah, it's hot in there. So, I'm gonna give that, I'm gonna let that come back up to temperature. I'm probably gonna rotate it one last time after that, so that everything's nice and even. And then I'm gonna put it under the press. What am I gonna do? Press, power hammer. I'm trying to decide. I'm going to use the power hammer, which means I got to turn that on. So anyways, to get that warmed up, I'm going to rotate it probably at least 2, maybe 3 more times. That way I also give the hammer a little bit of time to warm up before I start hitting on it. So I'm going to turn you back to the forge while I get that hammer set up. Or, yeah. plan has changed. We are not using the hammer, I'm using the press. For some reason, the hammer is not kicking on. So, what I'm gonna do is I'm gonna cut this feed. So, Gabe, when you instead of tiling it, if you just forge it out off the bar, there is a kind of a cladding, but it's just not all the way from the spine or from the edge to the spine. It's just halfway through the billet. Because I'm not going to be tiling this, I'm just going to be, or once it's welded up, or at least one of the options is not going to be tiling it. I mean, I can do a few options. Now that I'm aware that I'm going to have a bunch of material, I'll probably experiment. I'll do one that is just forged straight off the bar. I'll do one that is tiled. I might do the tip weld technique that I showed you guys last time. I'll do it intentionally as part of a plan rather than it being a freak out and accident and having to figure that out. And then I'm curious about the ladder. I do have my laddering dies, so I'm curious about laddering it and what that'll look like. So I might do a ladder as well. I hate that it wastes a ton of material. It wastes so much material, but I'm curious. So I feel like I gotta try it. Anyways, I'm gonna cut this feed. I'm gonna get another one going, and then, well, actually, I should wait to cut the feed because I need to set the weld on this billet. I'm gonna rotate this real quick. Give that 2 minutes to warm up. Then I'll set the weld. I'll get it back in the forge. Then we'll cut the feed. I'll come right back. And then we'll just keep going. We'll talk some more. All right, so let's get you guys. I'll have you hang out here for a second while I create some space. Learn how to operate a camera. All right, these back up. How's that? Hey, looks like I'm trying to do something interesting. Okay. Come straight out of the forge into the press, set that weld, and right back into the forge. So when I set my welds, I know I've said this before to my Patreon peeps. Just realized this is slightly off kilter. Anyways, when I set my weld, I'm not trying to smash the hell out of this thing. I'm just trying to get compression through the entire height of the billet, but I want to also kind of preserve some of that height for future rounds of forging, just to continue to encourage it to go back together in usually it's the first 3 rounds of forge welding before I even start thinking about forging along the edge. So I'll probably do an overall compression of maybe like a 1/4 of an inch to 3/8 of an inch. I usually do about 1/8 of an inch at a time, so about a 1/16 of an inch reduction from the top and the bottom to compress the billet for an overall 1/8 of an inch. So I'll munch it on the top and the bottom, I'll flip it over, I'll munch it again. I'll probably actually do that 4 rounds, so maybe a total of a 1/2 of an inch. But I need to go at least 3/4 of an inch to get down to a square. And then, yeah, so, and then that's it. All right, I'm gonna rotate it one last time. I'm pretty sure I said I was gonna pull it out that time, but I changed my mind. I decided to, yeah, just give it a couple more minutes. Because I could just visually see that the heat was not even, but it's pretty damn close now. Here we go. Everything is nice and tight. I'm gonna get this back in the forge. Alright, so I got that back in the forge. Everything's nice and tight. My brother's in the house. What's up, dude? My brother Lou. It's El Malmasi. 6850, my man. Dude, I just got really excited that you're in here, dude. That's great. Anyways, I got the steel back in the forge. It's gonna soak now. I'm actually gonna turn this pressure down. It's at 30 presently. I'm gonna pull it all the way down to about 15. And I'm gonna soften this flame so that we're operating in a fuel-rich environment. Get you in here a little bit closer. You can see, I'm going to adjust this flame a little bit. So for me, that's a little too soft, but that's also a little too lean. I want it somewhere in between. I like that. Call that good. And now, I'm also going to set a timer real quick. We got technology, we got phones, let's use it, baby. Let's use it. So, I'm gonna set it for like 20 minutes. Set it for at least 20 minutes. And I'll come back and the temperature of the forge is gonna come down just a little bit. But it's still gonna be damn hot in there. Plenty hot to, for the atoms within the material to kind of be bouncing around and moving around. And now that they're physically touching all those parts, like you showed you, they're very tight now. So now that they're all touching at I almost hit an anatomical atomic level, they're going to start trading atoms across those boundaries of those individual pieces, and they're going to start developing what is called a diffusion welded bond. So that's the atoms trading size and creating a molecular bond at the atomic level. So every once in a while, because the source of heat in the forge is it comes in through the top, cycles around the side. This side over here is always going to be the hottest, so I am going to continue to rotate it probably every 5 to 10 minutes or so. But timer's going to help me keep track of time, but it's also important to kind of like not get too distracted. So let's see. My sister just jumped in the stream too. TRM awesome. Get it, brute. Yeah. Actually, I think I'm gonna go 30. Because why not? We got time. All right. So I'm gonna cut the stream. I'm gonna get another one going in just a few minutes. I decided I have to go to the bathroom. Look at me, I'm a human. Anyways, I'm gonna show you a video or a pic real quick of how that steel's looking though now. It looks really nice. The temperature looks really nice and even. Got my timer set so I can stop fussing with that. What's up, Royal? Woo! Alright, turn this around. Look at that. It hot, baby. It is hot. All right. Okay, so I'm gonna get in there. Probably actually not mad at how even that is right now. I love it. I am gonna rotate it though. Like I said, I'm probably gonna be rotating it every few minutes. Whatever, a couple minutes to 5 minutes, just to try to keep things nice and even. I don't know what else to say right now other than I gotta go to the bathroom and I can't think straight. But I will be right back. I'll get another live stream going. People in the Patreon, I'm gonna get a new link to you guys, get that posted up so you guys can jump in and watch, or you can hang out here on YouTube and wait. One way or another, I'll be back. Real quick, Rick has another question. He says, do you have any idea what the temp in the forge is for the 20 minutes? The temperature in the forge is probably hovering around 2,000, maybe just under 2,000. It doesn't need to be super hot. It just needs to be, I mean, honestly, you could pull the temperature down. If you go back to my conversation with Will Brigham, we talk about time and temperature in regards to allowing wells, forge wells to set. You could, as long as you're above critical, which is like 1,300 or 1,350, 1,400 degrees, as long as you're above critical, the atoms are starting to move within the material enough to start doing its thing. The problem is, at those lower temperatures, it takes a long time. But to get that diffusion welded bond, I don't need to be at 2,200 degrees. I never run my forge hotter than about 2,200 degrees. I've definitely ran it. It can definitely get there, but I don't need it to run that hot. So I like to turn the temperature down, so because I want it to sit and soak for a long period of time, but I still want it to be active. I want those atoms to be active within the material. So my thought process is bring it down a little bit, because it doesn't have to be crazy hot, but it still needs to be hot enough so that the atoms are moving around pretty rapidly. But yeah, just not so crazy hot for like a 20 to 30 minute soak. Most often I do like a 20-minute soak. But again, that's just to give the material time to develop that diffusion welded bond. If you want to go longer, go longer. Pull the you can even, if your forge can handle it, pull the temperature down just a little bit more. So, anyways, hope that answers your question, and I'll be right back.